remember that OH ions represent basic solutions, so that would be an increase in pH greater than 7 is a basic pH. And then adding H plus ions causes a decrease in the pH, so it would make it more acidic. So for this reaction that we have magnesium hydroxide solid dissolving, consider what happens when you do these changes. So first of all, if we add hydroxide, hydroxide is a product, and so if we think back to our original Le Chatelier principles, if we add, we shift away from it, right? So if we're adding a product, then we will shift towards the reactants, so the equilibrium will shift left. So that's a very simple Le Chatelier's principle consideration. Because the OH is present. If you don't have the OH present or the H plus present, it makes it a little bit more difficult. So, for example, if we add H plus ions, so maybe we're adding a different type of acid, like nitric acid, HNO3, to the mix. What does that do? Well, the H will combine with the hydroxide to form water. And so when it forms water, then it's really removing the OH from the reaction. So this is a removing case of Le Chatelier's principle when you add H plus for this reaction specifically. And so when we remove, we said that we shift towards. So the equilibrium would shift to the right because you have to shift towards where the removal happened to create more of what was removed. Okay? So in this particular instance, when you are shifting towards the products, you're shifting towards the side with the ions, that would make it a greater solubility because more would be present in ion form at equilibrium. But then if you're shifting to the left, you're shifting towards the solid side, the reactant side, and so then that would result in a lower solubility, less solubility, because if you have more solid present than ions, then it's not as dissolved, which is the whole point of what solubility is. Okay, so another thing to consider is the relative strength of the acid or base involved. We have strong acids and strong and weak acids, and strong bases and weak bases, and that's in a later unit, but we've talked about that a little bit. Strong acids and strong bases completely ionize, completely dissolved, and weaks only partially. So they're the ones that actually have the solubility, or like the KSP kind of thing. So the general rule is that if an anion forms a weak acid with H+, then the salt that contains that anion will show increased solubility in an acidic solution. So some common ions that work this way are hydroxide, sulfide, oxalate, and chromate ions. Salts that contain these ions are much more soluble in an acidic solution than just in pure water. So in those cases, you would actually dissolve them in acidic solutions than pure water so that you can get more of it to be dissolved. So this is the multiple choice question, where the dissolution of calcium fluoride is represented by the equilibrium system shown at 25 degrees Celsius. So what that means is we have both working together for the overall solubility, dissolution of the calcium fluoride. So it's in an acidic solution because of the HF, the hydrofluoric acid. So that tells us right now that it is acidic. Okay. So the F ions produced when the weak acid will dissociate, and then if the calcium fluoride is added to equal volumes of the following two solutions, which solution will the most calcium fluoride dissolve? So this is saying that we have like a beaker full of the hydrofluoric acid, and then we're putting the calcium fluoride into it. Okay, and then we want to know if we put calcium fluoride into one of these four options, which one will have the best chance for solubility? Well, it all has to do with what you're doing. So water, H2O, means that there's not going to be any common ion, so that's going to just be its normal situation. For B, the nitric acid, the important part for what you're adding here is the H+, because that's a common ion that's involved in our system. Then for the NaOH, we're adding OH ions, which, just like we talked about before, OH will react with H+ to form water. Okay? And then if it's in a saturated solution of calcium fluoride, then it's adding, then like you have both calcium fluoride, calcium and fluoride ions present, so both of those are being added here. So the best choice where the most calcium fluoride will dissolve is actually in the acidic solution for B. Because what happens is if you add the calcium fluoride into the acidic solution, the fluoride ions will combine with the H+, shifting that bottom equation back this way. And so if you're adding H+, the fluoride will react with the H+ to go back, removing the F-. And so if you remove the fluoride ion, then the top reaction is going to have to shift right to produce more fluoride ions. So when you put it in acidic solution, then it will pull away the fluorides from the solution. So then the solid has to dissolve to create more fluorides. Okay? So when you think about pH and solubility, it's a little bit more involved. We'll talk more about pH and all that kind of stuff in a different unit.